An overview of the machine learning process. To help you gain a better understanding of the overall machine learning process, I would like to summarize it in a simple four-phase flowchart. Number 1, data preparation. Number 2, algorithm selection. Number 3, model compilation. Number 4, prediction and evaluation stage. As one may see in the above diagram, there are four major steps involved during a typical machine learning task. The explanation of the steps are as explained in the following slides. From my personal experience with machine learning, I would say that the data preparation phase is the most crucial and important. Number 1. The data preparation stage. During this stage, the data is prepared for the algorithm. Data needs to be carefully handled before sent into a machine learning algorithm. In the same way that we require food to be cooked before consumption, an algorithm requires its fuel, data, to be carefully prepared before being fed into it. Simply put, the nature of effort invested into perfecting the fuel, data, for the algorithm will have a direct impact on the computational power and predictive power of the model and the quality of predictions, because the data on which the model is trained determines how it will make predictions for its lifespan. During the preparation stage of the data, one is required to select the feature that they would like to predict, called the target vector, and set it aside from the features that will be used to predict, called the features matrix. Hence, the greater the quantity of data, the better the quality of predictions. This is because the training process spans a longer duration, thereby impacting the level of insight obtained during the learning process. A good example of preparing the data would be deciding how to handle those rows in which a field has missing values. Do we delete those rows entirely? Do we fill the missing values with the average value in that specific column? Number 2, the algorithm selection stage. The algorithm refers to the particular methodology that you will select. The algorithm is that component of the machine learning framework which does the learning. When the algorithm is exposed to or applied to the dataset, it will analyze each feature and attempt to learn trends and patterns in the dataset. It is good to understand that the type of algorithm that one selects for the task at hand is dependent on the nature and type of data you are working with. There are several categories and types of algorithms. Some categories include regression, classification, clustering. Some types include linear regression, logistic regression, Birch algorithm. We will explore a variety of algorithms in detail at a later stage in this course. Number 3, the model compilation stage. During this stage, there are essential training events that occur. You see, most if not all algorithms can be represented as a mathematical expression, and a model is successfully compiled and completed when the algorithm has successfully found the best useful coefficients to use in the formula. Think of a simple line graph. F of x is equal to mx plus c. During the model compilation stage, the model will attempt to find the most suitable coefficients for m and c by applying the algorithm to the data. Remember that the algorithm does the learning. The model can be thought of as being the memory during the training process, which remembers the teachings and stores it for future use. As the model finds suitable coefficients, it gradually builds up, bigger, better, and possessing higher predictive power. Model compilation is completed successfully when you are able to use the model itself to make predictions on test values. The prediction and evaluation stage. Before we conduct a prediction using test values with our model, we should proceed to evaluate the model's predictive power. The evaluation of a model gives us, the human being, insight into the accuracy and usefulness of a model, because a model is only as useful as its worst prediction. Evaluation of a model is done using evaluation metrics. These are specific formulae that are applied to a model to test and see how accurate the predictions are on data that it has never seen before. To increase our level of understanding of the four-phase process, let us analyze a simple example. A simple machine learning example. To increase your level of relatability, a very interesting point I should mention before we look at our example is, thinking back at your days of school, do you remember your first mathematics class in which you were introduced to drawing a line of best fit across the data points scattered on a scatter plot? This line of best fit required that the number of data points located above the line was equal to the number of data points below the line. Believe it or not, what your mathematics teacher did not tell you was that the actions you were performing during that very moment was a simple form or type of machine learning technique. It is called linear regression. Now, let's move on to our example, keeping in mind the teachings learned in school. Number 1. The data preparation phase. Let's say we have a simple data set that comprises two features, crime rate and house price. Our data is in good condition and needs no further actions to be taken for preparation. We would like to predict the value of house price, therefore making it our target vector and dependent variable. As we know, the dependent variable will be found on the y-axis. We will use the remaining features, namely crime rate, to make the predictions, therefore making it our features matrix, an independent variable, which will place it along the x-axis. To gain further insight into our data, let us plot a visualization of the data as seen on the next slide. As can be seen from the visualization, we have a scatter plot showing us the position of the data points relative to each other. Looking at the graph and data points, one can anticipate that there is a direct relationship between crime rate and house price, because as x increases, so does y. Number 2. The algorithm selection phase. In our particular problem, we wish to predict house prices. The house price feature takes the form of numerical data, that is, quantitative values. Go back one slide and look at the data focusing on the house price R column. Quantitative or numerical data will tell us the amount, quantity, or measurement of something. Notice these values are continuous. There is no fixed or predefined range within which the values can belong. That is why they are called continuous. Now, to predict values of this nature, we will require a method or algorithm that will be able to learn the trend in the dataset once off and will allow us to use the model for making future predictions pertaining to house prices. The method or algorithm that we would select will be the straight line graph or linear regression. It has the following formula: y is equal to mx plus c. Let us analyze this formula. Number 3. The model compilation phase. Now that we have effectively selected the algorithm to utilize, we may proceed to expose the algorithm to the data in order to obtain a successful, powerful model. When an algorithm is applied to data, the process of forming the model involves mathematics and statistics. The model needs to carefully choose and select the best coefficients to make use of in the formula. One must understand that the model's digital compilation and selection of coefficients that occurs during the machine learning process tends to happen in back-end processes that cannot be seen by the human being. However, when brought forward into the light, each of these intrinsic processes can be expressed mathematically in the form of formulae and equations, and one is able to see exactly how the model has reached those conclusions. Y is equal to mx plus c, where y is the value for the y variable, in our case house price, x is the value for the x variable, in our case crime rate, m is the gradient of the graph, c is the y value at the point the gradient intercepts the y-axis, it is the y-intercept. Upon doing the mathematics manually, one will find m is equal to y2 minus y1 over x2 minus x1. Two data points need to be substituted into the respective placeholders. To calculate the value of c, one needs to make it the subject of the formula by substituting a third data point into the equation. Let us proceed to calculate the equation. To calculate m, let us use the data points 10 and 10,000, 20 and 20,000. m is equal to y2 minus y1 over x2 minus x1 is equal to 20,000 minus 10,000 over 20 minus 10 is equal to 1,000. So now we have y is equal to 1,000x plus c. To calculate the value of the intercept c, let us use the data point 60 and 60,000. 60,000 is equal to 1,000 into 60 plus c. c is equal to 0. Hence, the final calculation or model will be y is equal to 1000x. The evaluation and prediction stage. Now that we have successfully compiled a model, we may proceed to evaluate its predictive power and use it to make predictions for future scenarios. Suppose we have a community in which the crime rate is 70%. We wish to know the approximate price of a house based on this figure. With machine learning, making a future prediction becomes simple. We simply make use of the model, predicting the house price for a 70% crime rate. Y is equal to 1000x, house price is equal to 1000 into 70,000 rand. Given the fact that I have used a simple example scenario to work with, one is able to see that the model's prediction is 100% accurate if the data follows a continuous trend as we have seen in the table and scatter plot. We may confidently say that a crime rate of 70% will cause a house price to be 70,000 rand. Hence, we can assume that our model has achieved 100% accuracy in its predictions. The reason as to why I call the stage evaluation and prediction is because I believe that it is good practice to evaluate model performance before attempting to make a prediction. This gives us insight into our model's margin of error, thereby notifying us of up to what level or degree our model could be incorrect in its prediction. Conclusion. In this tutorial, we have grasped knowledge of the methodology, terms, and nature of machine learning in the real world. I do hope that you have obtained a good understanding of the general machine learning framework. Learning is like development. There is no end to it. I look forward to teaching and learning along with you. Thank you for taking time to read and watch up to the end of my first tutorial. Future videos and tutorials will explore machine learning in much more detail along with other interesting topics. Thank you.